in the given graph they are asking the relationship between the Hamiltonian and the Eulerian. Now we know that if the graph is if a graph is Hamiltonian, then it is not necessary that it will be Eulerian, and converse is also very true. One example I am going to give. A graph is going to be called as a Hamilton graph if in the graph there is a cycle who is going to cover all the vertices of a graph, then it is going to be called as a Hamilton graph. As for example, one graph I am going to take, this graph. Let us suppose this graph here is Hamilton graph, because if I am going to take a cycle, let us suppose any cycle, this is a cycle which is covering all the 4 vertices of the given graph, so therefore is Hamiltonian graph. So now this is not a Eulerian graph because here this is not there and even this is not there in the given Hamilton path. So now example for the Hamilton graph. In the Hamilton graph there is, let us suppose we have the 6 vertices. So now Hamilton graph means there is a edge between each of every vertices with all other vertices. So here I am going to take this one is a graph, and with this set of vertices all the edges are there from this is a graph is Eulerian. But whether this is any cycle is there which consists of all the vertices of the graph, no cycle. So therefore the graph is neither Hamiltonian, is neither Eulerian, nor Eulerian is going to be Hamiltonian. That is the options.